Most AI demos I am seeing everywhere are hiding a secret. They show you what the agent did, but know how it thought in order to do it. They hide the messy, iterative process of failure, correction, and learning. And this is why impressive prototypes so often collapse in production. They lack a robust harness, which is the system that enables the AI to not just act, but also to improve. By the end of this video, you will understand the key design patterns behind agentic harnesses, how these systems are evolving to optimize themselves, and the real bottlenecks standing in the way of truly autonomous AI systems. We will cover the 3 core design patterns for these harnesses, but pay close attention to the second one. It seems almost too simple, but it is the key to unlocking long-term autonomy. So let's dive in. The simple formula of LLM plus prompts plus tools is not enough for long, complex tasks. This is where the harness comes in, the system surrounding the base model that orchestrates the execution, manages memory, and defines the agent's workflow. Think of it as an OS for intelligence. 3 design patterns are becoming standard. First, workflow automation. In this case, the agent operates in a loop, it plans, executes, and observes, and of course, improve. It is a runtime letting the model analyze its own failures. Andrews Karpathy's auto research project is a clean example of this. It's an agent that runs experiments with a code base until it finds a better solution. But a workflow is useless if the agent cannot remember what it has learned. This brings us to the second pattern, is the file system, a persistent memory. An agent's context window is finite short-term memory. For any task lasting more than a few or 5 minutes, it needs long-term memory. And the simplest, most robust solution is files and folders. The harness gives the agent tools like read or write. For example, an agent researching a topic could write its findings to research notes.txt and resume its work later without starting from scratch. It is the difference between holding a thought and writing it in a lab notebook. So the question is, what if the problem is too big to handle alone? That requires the third pattern, sub-agents and backend jobs. A harness allows a primary agent to have many sub-agents to delegate tasks, run experiments concurrently, and then merge the results. This isn't just about speed, it is about managing complexity. For example, a primary agent could take 2 tasks, 2 sub-agents, they would analyze the code base, one for security, one for architecture, then synthesize their findings for a more holistic refactor. But just having a good workflow, that is not enough. The question is, what happens when the workflow itself is the problem? And that brings us to the next level of optimization. The interesting shift in agentic engineering is what we actually optimize. Let me explain. It started with prompts, then we moved to optimizing the context that fits the prompt, but the real leap is when the object of optimization becomes the harness. The code itself. And this is the core idea behind projects like Meta Harness and Self-Thought Optimizer or STOP. Here's the idea. Instead of a human engineer debugging an agent's harness, we give that job to another AI. And this Meta agent can propose edits to the harness code itself. It can run tests and validate if the changes lead to better performance. And this is recursive self-improvement. in its most practical form. The search space is no longer just the solution to a problem, but the design of the problem solver itself. And by the way, I have made a video about the recursive self-improvement, or RSI, and I will lay you the link in the description down below, so check it out. I know all of this sounds very promising, but the path to fully autonomous self-improving systems is blocked by some fundamental challenges. The biggest one is evaluation. Evolutionary loops work best when you have a clear, fast, and objective fitness function. It is easy for an agent to optimize code for a benchmark like SWE bench because there are unit tests. The agent knows immediately if it changed worked. But the question is, what is the evaluation for a good scientific taste or long-term code maintainability? These are much more fuzzy, human-centric concepts. An agent can easily p-hack its way to a good metric without achieving a genuine good outcome, a classic form of reward hacking. And this also leads to problems like diversity collapse, where an evolutionary search finds one good enough solution and churns out minor variations, failing to explore the full design space. Now, here's the part that confuses more people. The goal of recursive self-improvement, it is not to make humans obsolete. It is to move us up to the stack. Our role is from being the direct implementer to being the designer of the system, the curator of the goals, and the final arbiter of what good actually means. The challenge is to build systems where human feedback is a natural part of the loop, not an afterthought. So, the frontier of AI is moving beyond simply scaling up models. It is about building the systems that allow these models to learn, adapt, and improve in the wild. The harness is the architecture for that ambition. The key takeaway of this video for you is the following. The next time you see an impressive AI agent demo, don't just look at the final output. Instead, ask yourself, what is the harness? How does it manage state? How does it learn from failure? And who is improving the system itself? Because that is where the most important engineering is actually happening. And if you are an engineer or researcher building these systems, this is your new playground. The models may get the headlines, but the harnesses is what's currently defining the frontier. And if you like this video, consider subscribing to the channel for more deep dives into AI engineering topics. Let me know in the comments if you have seen some harness pattern actually working in an AI system that is in production. Thank you very much for watching and see you in the next one. Bye.